8.3 is going to be going over the trig ratios. We're going to use them to find missing side lengths of a right triangle. So when we have trig ratios, we want to make sure that we know how to identify the opposite, adjacent, and hypotenuse sides. And the way that you're going to label those is always going to be determined on what point you are looking at. So in this first one, they want us to label the sides of the triangle using point C as the reference. So from point C, we're going to use that to label the opposite and adjacent side. The hypotenuse is always going to be in the same spot, doesn't matter what point you're using, and it's always going to be across from that right angle. And then the opposite side is going to be the one across from the point we are working with. So if we're working with point C, the opposite would be across from that one, leaving the adjacent side connected to it. And adjacent means next to, which makes sense that it would be connected to point C. Now if we use that exact same triangle, but now we're using point A as a reference, the way that we label it is going to be slightly different. The hypotenuse is still going to be in the same place because it's opposite of the right angle, but this time the opposite is going to be over on the left side, and then the adjacent is going to be on the bottom. So it just depends on what point we are using as a reference point, whether it's the point C or point A. One other thing, when we are labeling the triangles, we use capital letters normally for the 3 points going around. And then the lowercase letters are going to be the sides opposite of them. So opposite of A would be a lowercase a, opposite of B would be a lowercase b, and then opposite of C is a lowercase c. So the capital ones, those are for the points or the vertexes of the triangle. Lowercase, those are talking about the side lengths. All right, so now let's go over the trig ratios. And for the trig ratios, a phrase that we are going to use to help us remember how to set them up is called SOHCAHTOA. Let's look at the first one. When you have a triangle, and if we use this as our reference point in the bottom corner, let's call it point A, we would have our hypotenuse over here, our opposite, and then our adjacent. The S in SOHCAHTOA, that stands for the sine function. So this one, if we find the sine of A, that is going to be equal to, and then the lowercase o and the h, those stand for, the two sides we are going to be using. So we're going to be using the opposite and the hypotenuse. And ratios mean fractions, so we're going to set it up as a fraction. So sine of angle A is equal to the opposite side over the hypotenuse. So we are normally going to be using these ratios to find missing side lengths or just to set up ratios. And we're going to go over examples of what that looks like. But this is how you would set up your sine function. Then we have the COA part, and that one is the C. With that one, we are going to, again, use a right triangle. And if we use reference point A at the bottom again, we would have our opposite across from it, adjacent, which is connected, and then our hypotenuse opposite of that right angle. The C stands for cosine, so we're going to do COS, which is stands for cosine, of angle A equals, and the A and the H tells us what two sides we're going to set up as a fraction. So cosine is adjacent over hypotenuse. So for cosine, you use the side connected to the point, and then the hypotenuse. where when we were doing our sine, we used the opposite one and then the hypotenuse. That leaves our third and last trig ratio, which is TOA, the TOA part, and that stands for tangent. And again, we use a right triangle, and if we use A again as our reference point and label our sides, we have opposite, adjacent, and hypotenuse. Tangent is TAN, so tangent of angle A, equals, and the OA stands for opposite over adjacent. And that gives us our three trig ratios that we're going to use to help either set up fractions or solve for missing sides. Okay, so let's do some examples where we set up some fractions. For example 1, they want us to find the sine, cosine, and tangent of angle S. So first you want to find that angle and then use that to label the opposite and the adjacent side. And then also our hypotenuse. And we're still going to be using SOHCAHTOA. If we start with sine, we would set it up as sine of angle S. So the angle letter changes depending on what the problem tells you to use. So we would do sine of S equals our opposite side of 60 over 65. And with these problems, you do want to simplify your fractions. You can use a calculator to do it for you, or you can just simplify them yourself. 60 over 65, those both can be divided by 5, and we would get 12 over 13. Whoops. And that would be our sine of angle S. And we're going to leave them as fractions when possible. Then if we do our cosine of angle S, that is equal to the adjacent side over the hypotenuse. And that would mean we would put 25 over 65, which both can be divided by 5 again to get 5 over 13. That leaves our last function that we need to find, the tangent function. We would set that up as tangent of S equals opposite over adjacent, and that would be 60 over 25. And when we simplify that, divide them both by 5, we would get 12 over 5. So for these ones, they gave us all three sides, and what we are expected to do is just write the ratios or the fractions for the answers. So you should go ahead, pause the video, and try example 2, and then hit play to see if you got your answers correct. Same type of example as example 1. For this problem, we're going to find the sine, cosine, and tangent of angle W, which means 30 is our opposite side and 16 is our adjacent side. Our hypotenuse would not change no matter which angle we were using, so we're going to have our hypotenuse as 34. Sine is opposite over hypotenuse, and that would end up being 30 over 34. And if we divide those both by 2, we would get 15 over 17 for our simplified answer. Then we have to do our cosine of W, and cosine is our adjacent 16 over our hypotenuse 34. And again, if we divide these both by 2, we would get 8 over 17. Then our third side is tangent of W, and tangent is opposite over adjacent. That would give us 30 over 16. And when we simplify, divide them by 2, we would get 15 over 8 as our answer. All right, so sometimes you are going to be just asked to find the sine, cosine, and tangent where you have all three sides. And when that happens, you are just going to be setting up your fraction answers. Other times, you are going to be asked to find values of x. So the first thing you're going to want to do is, if they only give you one of the angles, one thing I want you to know is when you are labeling the sides and you're trying to find your reference angle, you are only going to use the acute angles. So we're never going to use the right angle as a reference point. And in this one, our reference angle is going to be 31 degrees. And if this is our reference angle, the 17 is the opposite side, and the x would be our adjacent side. You can label your hypotenuse, but in this problem, we were not given that length, so we're not going to be able to use that one. Then you're going to figure out which one of our three trig ratios we are going to use. If we look at our triangle, we were given the length of the opposite, and we are looking for the length of the adjacent. So we're going to look at our three trig ratios to figure out which one uses opposite and adjacent. And that is going to end up being our tangent function. And when we set that up, we're going to do tangent, and instead of a letter for the angle, because we know the angle measurement, we're going to put in 31. And that's going to go in parentheses. So tangent 31 equals, and then we set up our fraction, opposite over adjacent, 17 over x. Once you have the equation set up, we need to solve so x is by itself. When this happens, when you have your variable in the denominator, we are going to cross multiply, just like we did last chapter. So we're going to take the top of one side and multiply it by the bottom of the opposite side. That is going to end up giving us x times the tangent of 31 equals 17. And our goal is to get x by itself. So we're going to divide both sides by the tangent of 31. That means that x would be by itself, and it would be equal to 17 over the tangent of 31. Once you get to this point, then you can type it into your calculator. And on the yellow classroom calculators, above the 8, 9, or the 7, 8, 9 buttons, there are buttons that say sine, cosine, and tangent. And what you're going to do, you are going to type in on your calculator 17 divided by, and then you'll hit the tangent button and put 31. That will give us our answer. And for these problems, you are going to round to 4 places behind the decimal point. So you're going to put 28.2928. And that would be our value for x. And with these ones, you are going to need a calculator to figure out what the sine or cosine is of these different ratios. All right, so we're going to solve some more problems with that, but some vocabulary words that you might need to know are angle of depression and angle of elevation. Angle of depression is when you are at a higher level, so say you were in a tree, and you were looking down from the top of that tree. The angle of depression is going to be if you looked straight out that line, and then from there you looked down a distance, the angle formed between that straight line going down, that is the angle of depression. So angle of depression is from straight out looking down. And you always have to have that line of reference so that we can get our right triangles here. So it's always going to be from that straight line. Same thing from the angle of elevation, except this time you're standing on the ground and you have that your eye line that's going straight out. And then the angle of elevation would be if you were to look up at an object. So angle of elevation, you're elevating your eyesight and it's going down. Angle of depression, you are going and you're looking down. And again, we have to use that straight line as a reference so that we can end up with our right triangles, and that allows us to use our sine, cosine, tangent to find missing measurements. All right, so now we're going to look at example 4 and example 5. These ones are word problems that describe a picture. So for example 4, you are at the top of a roller coaster 100 feet above the ground. So we are over here, and we talked about that was 100 feet from the ground. The angle of depression is 44 degrees. So angle of depression starts at a horizontal line and goes down. That is why the 44 is in this top corner over there. They want us to figure out about how far do you ride down the hill, and we are going to be solving for x. If we use this 44 degrees as our reference point, our right angle is in the top right corner, we would have our hypotenuse, our opposite, which is 100, and then our adjacent. And we need to figure out which one of our SOHCAHTOA we are going to use. We know the length of the opposite, and we are looking for the length of the hypotenuse. So we want to use the ratio that uses opposite and a hypotenuse, and that would be our sine function. When we set that up, it's going to be sine of the angle we are using, 44 degrees, equals our opposite side, 100, over our hypotenuse, x. And again, from here, we are going to cross multiply and solve. So if we cross multiply, we're going to have x times sine of 44 equals 100. And our goal is to get x by itself. So we are going to divide both sides by the sine of 44. Once x is by itself, then you are able to type this into a calculator. So you don't want to use the calculator until the very last step. So on your calculator, you're going to type 100 divided by the sine of 44. And when you type that in, you want to make sure that the sine of 44, you have those parentheses around the angle measurement. And we're going to round it to 4 decimal points. So we have 143.9557. And you want to make sure you are practicing typing this into your calculator to make sure you can get the right answers. Okay. So now, example 5. A railroad crossing arm that is 20 feet long is stuck at an angle of elevation of 35. So that started at a horizontal line and it went up, and that's why the 35 is in that bottom left corner. They want us to find the lengths of x and y. So with these, you want to pick one of them to start with. So you're either going to start with x or y. If we start...
I didn't get that. Could you try again?
Oh.
By the way, if you have another request, you don't need to say...
Sorry about that. So if we start with x, we have that side, which is the opposite of the 35 degrees, and they told us the length of the hypotenuse. And when we want to solve for x, we need the side that uses opposite and hypotenuse, which would be our sine function. And we would set that up as sine of 35 equals our opposite side x over 20. Once you have your equation, then you can set it up. So we can cross multiply. This time it's 1 times x, which would be x equals, and then 20 times the sine of 35. This time, once we cross multiplied, x was already by itself. When that happens, then you can just type that into your calculator right after that step. So you would type 20 sine and then 35. Again, we're going to round to 4 decimal points, and that will give us 11.4715 for our answer. So the height here is about 11.4715. Now we're going to find the value of y. And when you are finding a second value in your triangle, you are going to want to use the side you're looking for and then the original side you were given. And the reason we're going to do that is because our x value, that was an approximate value. So if we were to use that in our second equation to find y, our answer is not going to be as accurate as it can be. So you always want to use the new side you're looking for and then the original side length that they gave you. That way your answers are going to be more accurate. And with this one, solving for y, we have our adjacent and then our hypotenuse, which means we are going to use cosine to find our missing value. And if we set that up of cosine of 35, that is going to be equal to y over 20. Then with that equation, we can cross multiply, and that will give us y equals 20 times the cosine of 35. And because y is by itself, we can go ahead and just type that into our calculator, which gives us about 16.3830. And that would be the length of the bottom of our triangle. Okay. So with these ones, you are going to use your sine, cosine, or tangent when they give you an angle measurement, and it's not one of our 45, 45, 90 or our 30, 60, 90 triangles. If it's one of those, you can use your special right triangle information. If it's not one of our special right triangles and you only know the right angle and one other angle, that is when you're going to use sine, cosine, or tangent. So looking at example 6 here, they want us to use special right triangles to find the sine, cosine, and tangent of the 30-degree angle. So this special right triangle, they already gave us all of the side lengths. So the one opposite of 30 is 1, and then we have our adjacent, and then our hypotenuse. And they want us to set up sine, cosine, and tangent of 30. If we had sine of 30, sine is opposite over hypotenuse. That would be 1 over 2. Cosine of 30 is going to be adjacent over hypotenuse, and that would be the square root of 3 over 2. Tangent of 30 is opposite over adjacent, and that would be 1 over the square root of 3. And now we've done this in a lot of our warm-up problems, but you have to rationalize your fractions. So you multiply both the top and the bottom by the square root of 3. The important thing you need to know is the square root of 3 times the square root of 3. When you multiply those together, it does not disappear. They come out to equal 3. So you have to make sure that you are not forgetting about that denominator there. And that was a common mistake on our last quiz. So make sure that when you multiply those, you're not just letting them disappear. You are keeping it as part of your fraction. Okay, so I know our notes are a little bit long, so if you wanted to take a little break before you finish the video, you can go ahead and do that. Our next part is going to be word problems. For your word problems, sometimes there's going to be a picture for you, other times there won't be. So when there's not, always draw a picture to help you figure out the information and organize your thoughts. So for this example, if your distance from the foot of a tower is 20 meters and the angle of elevation is 40 degrees, find the height of the tower. So if we start drawing a tower here, and it says the distance from the foot of the tower is 20 meters. And again, it's okay to assume that we have a right angle there. And they told us the angle of elevation is 40. Angle of elevation starts at a horizontal line and then is going up. So that means this 40 degrees is going to be in this corner down here. They want us to find the height of the tower. That's where our variable will go. Once you have your triangles set up, we're going to solve them the exact same way we have with our other trig ratios. We're going to label our opposite side and our adjacent side. And our hypotenuse is always opposite of that right angle. Then we need to decide which one of our SOHCAHTOA we are going to use to, that's supposed to be a T. We are going to use to solve for the ratios. If we look at what they gave us the adjacent side of 20 meters, and we are looking for the opposite side, which is H. So adjacent and opposite means we are going to be using our tangent function. And when we set that up, it's going to be tangent of the angle we are given, 40, equals opposite over adjacent. Once you have that set up, then we just go ahead and solve. And this time, H would end up being by itself, and we would get 20 times the tangent of 40. Then you can use your calculator to type it in, and don't forget round to 4 decimal points. And this one would be 16.78. Whoa, oh, and this one's a special one, and it would end up being rounded up to 0.7820. And that's because of the 2 9s here. That would make this rounded up, and that would affect the 1 in front of it, making it a 2. So just make sure you're careful when you're rounding your numbers. Once we have that, that is the answer that they were looking for, so we are good to go. The next one, the angle of depression from the top of a building. So we're going to draw a building, and they're talking about angle of depression, and that is from a horizontal line looking down. That angle is 25 degrees. If you are 50 meters from the base of the building, how tall is it? And the base of the building is down here. So if we were to label this one 50, we can make a right triangle with the angle of depression, and that would make this distance up here also 50. And they want to figure out how tall the building is. So that is going to be this side over here on the right. using that angle of depression as our reference point, we're going to label our opposite side and our adjacent side, then the hypotenuse. Then we decide which one of our trig ratios we're going to use from our SOHCAHTOA. We were given the adjacent and we're looking for the opposite. And in this one, we're going to be setting up a sine function. Oh, I'm sorry, not the sine function. Opposite and adjacent, that is our tangent function. And when you set that up, you're going to do tangent of 25 equals our opposite side, x, over 50. Then you can cross multiply, and in this one we would get x equals 50 times the tangent of 25. And that is when your calculator comes in. So 50 times the tangent of 25, that equals 23.3. 3154. Again, we're going to round to 4 decimal points on all of these problems. With the word problems, first draw a picture, label your sides according to your reference point, so opposite, adjacent, and hypotenuse. Then you decide which one of your trig ratios you'll use, and then you are able to solve. All right, example 3. This one is a little bit of a longer problem, so make sure you pay close attention when you are drawing your picture. This one tells us the angle of elevation from you to the top of the mountain is 57.6 degrees. So if we draw, oh, that's a tree. Here's our mountain. And if we have the angle of elevation to the top, we'll draw our triangle. This angle is 57.6 degrees in our right triangle. It then says you walk 171 feet further from the mountain. So we started here, now we're going further away, and this distance in between these 2 points is 171. They tell us the new angle of elevation. Oops, that did not line up. That new angle of elevation is 24.6. They want us to find the original distance you were standing away from the mountain. In this problem, there are going to be 2 different things you are going to find. So we need to find the original distance we were standing, and that's the part that I highlighted in yellow here. That's going to be labeled X. Now, if we look at the 2 triangles formed, we have the smaller one that was formed with the original distance. And then we have the larger triangle that's formed when we walked 171 more feet away from the mountain. If we look at these 2 triangles, the yellow and the green one, they have one side in common. We are going to use that side to help us answer our question. So we're going to set up 2 different ratios. We are going to take from our original triangle, so the yellow triangle, 57.6 is our reference angle, and we're going to label our opposite and our adjacent. That's going to tell us to set up a tangent function, and that's going to be tangent of 57.6 equals y over x. So our opposite over our adjacent. Then we're going to look at our second triangle, the green one, the larger one on the outside. We're going to set up another function with that one. And in this one, we are still using opposite and adjacent, but you want to make sure that the adjacent is going to be x plus 171 because it has to be that full length of the adjacent side. And that tells us that the tangent of 24.6 is equal to y over x plus 171. Now with these two equations, your algebra of solving a system of equations is going to come in handy. So these two equations have two variables, an x and a y. What we're going to do is we are going to solve our first equation. We want to get y by itself. So our goal is to get y by itself. Right now it's being divided by x. So we're going to multiply both sides by x. And that is going to give us x times the tangent of 57.6 is equal to y. Now that we know what y is equal to, it's equal to x times the tangent of 57, we are going to replace the y in our second equation with that value. And this is again going back to our algebra skills. So we're going to have tangent of 24.6 equals, and we're replacing the y with x times the tangent of 57.6 over x plus 171. Now, looking at our equation, we only have one variable. We have our x. And this one is a little bit tricky because we're not quite done. So we're going to cross multiply to get rid of our two fractions. That'll give us x times the tangent of 57.6 equals, and we're going to multiply this together. Don't forget you need parentheses around the x plus 171 times the tangent of 24.6. Now, while looking at this, there's an x on the left and an x on the right. We need those x's to be on the same side of the equation. So we are going to multiply this tangent of 24.6 by both of these terms. So we're going to distribute there. And that's going to give us x times the tangent of 24.6 plus 171 times the tangent of 24.6. Once we distribute, we are able to get all of our x terms on the same side. So we're going to subtract x times the tangent of 24.6 on both sides. And these are not considered like terms because we're taking the tangent of different angles. So we're not able to simplify anything quite yet on these problems. Oops, forgot the 171. Okay, so once you are here, you have both of your x variables on the left side, and we need to figure out a way to get them by themselves. And that method we're going to use is we're going to take out the greatest common factor between those two terms on the left side. Both of them have an x, so that is what we are going to pull out. So we're going to take the x out, and then we're going to have tangent of 57.6 minus the tangent of 24.6 in the parentheses. And that is equal to 171 times the tangent of 24.6 still. All right, I know this has been a long one so far, but we are almost there. We just have one more step before we can type it all into our calculator. Our goal is to get x by itself. So we're going to divide both sides of our equation by this tangent of 57.6 minus the tangent of 24.6. And when you type this in, it is going to be a little bit, and you have to remember to type in your parentheses. Without the parentheses, you're going to end up getting the wrong answer. Okay. So with that, we got our x all by itself now. Now we can type it into our calculator. Oh, I probably did not give you enough workspace. Okay. So in your calculator, you are going to first type in that top part. So you're going to type in 171 tangent of 24.6 parenthesis. Then you are going to hit the division sign. After that, you need to make sure you put parentheses around the denominator. Otherwise, your calculator is not going to give you the right answer because it's only going to divide by one of those parts and not those parts subtracted from each other. So what you're going to do, you're going to put a parenthesis, and then you're going to type tangent of 57.6 parenthesis minus the tangent of 24.6, and then you would put the two parentheses, one to finish up the denominator, original ones, and then one to close out the tangent. Once you do that, that will give you your answer. And your x value is going to be about 70.0323 for your x value. Okay, I know that was a really long problem. They are not all going to be this complicated, but it is a good idea to understand how to solve a system of equations with all of these functions inside them. Make sure on the homework you try all of the problems, and then when we come back next week on Tuesday, ask a bunch of questions so that you can be ready for these if they show up on quizzes or tests.